Okay, so today's notes are going to be on solving algebraic equations. So you've already kind of done this in class in a lot of ways, but I'm going to go over a few vocabulary terms and things to make sure it's super clear. But we're going to start by writing our content objective regardless. I'm just going to be apply properties of equality to solve equations. By rewriting in progressively simpler terms or forms. So our language objective is going to be to describe the steps of problem solving by naming the properties of equality used. So you're going to be able to solve and then explain the properties of equality that you're using to solve. So the first thing we should do is go through the properties of equality. So on the left-hand side, I'm going to write the property, and then on the right-hand side, we will write the definition and an example. One thing I want us to assume, so I'm going to put a star here, assume in these definitions and examples A, B, and C are real numbers. So I believe at some point we will discuss imaginary numbers, which actually are a thing, but in all these examples, I'm talking about real numbers. So the first property is the reflexive property, or reflective, and that's just saying that something is equal to itself. So A is equal to A. So for example, 5 is equal to 5. We know that to be true. That is the reflexive property of equality. The next one we have is symmetric. So this says that if A is equal to B, then B is also equal to A. So you can write them on either side of the equation, it doesn't matter. So for example, if 1/2 is equal to 0.5, then 0.5 is equal to 1/2. They're the same thing. So the next one is transitive property. So the transitive property says that if A is equal to B and B is equal to C, then transitively A is equal to C. So our example for this one is if 2.5 is equal to 2.5, and similarly 2 and 1/2 is equal to 5 over 2, because we know these all to be equal, then 2.5 is also equal to 5 over 2. So that's the transitive property. The next one is substitution. So this says that if A is equal to B, then you can replace A with B, and vice versa. So A can be substituted for B, B can be substituted for A, or replace A can replace B, either way. So for example, if A is equal to B, we're going to start the same way, and 9, so that's a 9, plus A is equal to 15. Then similarly, 9 plus b would also be equal to 15. Because I can substitute b for a here, and it should be the same equation since a and b are equal. So those are some you might not be as familiar with the terms for, or you might not know the names of those properties of equality as well. But the next few, I'm guessing you probably know and are familiar and comfortable with using. I saw several of you use them in class when solving, but we're going to write them down regardless so you know that they are also properties of equality. So the first one is addition, and this just says that if a is equal to b, then a plus c is equal to b plus c. So for example, if x is equal to 12, sorry, I forgot the if, sorry about that. If x is equal to 12, then x plus 3 is equal to 12 plus 3. So this is when you're adding the same thing to both sides, they remain equal. This is the addition property of equality. So you can add it to both sides and it will stay the same. Similar with subtraction. So the subtraction property of equality says if a is equal to b, then a minus c is equal to b minus c. So our example is going to be the same, just with subtraction. So if x is equal to 12, then x minus 3 is equal to 12 minus 3. And same thing with multiplication and division. So those are going to be our next two. So multiplication, property of equality, if a is equal to b, then a times c is equal to b times c. I use stars so I don't mix them up with x's when I'm writing, just so you know. So for example, if x is equal to 12 again, then x times 3, or 3x if you chose to write it that way, is equal to 12 times 3. And you could use parentheses if you prefer. Last but not least, we have division. And I'm glad I can fit this all on one page. And this says that if a is equal to b, then a divided by c is equal to b divided by c. In our example, fitting the same pattern, if x is equal to 12, then x divided by 3 is equal to 12 divided by 3. So those are our properties of equality. When we're solving out in the next examples, we're going to label these different properties as we use them, but here they are with definitions and examples for your use. All right, so now let's do an example of solving a multi-step equation using some of these problems. So this is going to be an example, and I am wondering, what is the solution of negative 27 plus 6y equals 3y, or 3 times open parentheses, sorry, my bad, y minus 3. So that's negative 27 plus 6y equals 3 times open parentheses y minus 3. So I'm going to do 2 columns so we can write our steps on the right and the work on the left, or the work on the left, the steps on the right. I'm going to start by rewriting our equation. So I have negative 27 plus 6y is equal to 3 times y minus 3. And our first step, though we did not label this explicitly, it's not a property of equality, it's still a property, but the distributive property. So I'm going to distribute into the parentheses so that I can get rid of them. So our first step is going to be to use the distributive property. And then I'm going to simplify. So I have negative 27 plus 6y is equal to 3 times y is 3y, and then 3 times negative 3 is negative 9. So that's our first step. The next thing I'm going to do, you have a few different options. Please just follow along with what I'm doing. Though no, on your own, you could do it whichever way you please. I'm going to move the largest negative number, so that's my rationale for this next step. So I'm going to add 27. You could add the 9 if you prefer, or move the variables to the same side. All of those would work. But like I said, I'm choosing to move the largest negative. And this, because I'm adding it to both sides, this is the addition property. So then I have 6y is equal to 3y minus, sorry, no longer 9. It's going to be plus 18, because negative 9 plus 27 gives you positive 18. So then the next thing I want to do, I want to get my variables on the same side. So I'm going to move 3y to the other side so I don't end up with a negative over here. So I'm going to do minus 3y minus 3y. So I'm going, what I did just there was subtract 3y, which is the subtraction property. So then the 3y's on that side are gone. 6y minus 3y is 3y, and I still have that 18 on that side. Last step, I'm going to isolate y or get y by itself by dividing by 3, which, you guessed it, is the division property. So I end up with y is equal to 18 divided by 3, which is 6. So y is equal to 6 is my final answer. I'm going to give you guys a quick check really fast. So I abbreviate quick checks QC, but I am wondering, what is the solution of negative 2 times y minus 1 equals negative 16 plus y? So again, please write the steps on the right side so you can identify and practice our language objective of identifying the properties of equality. Pause it, try it on your own. I'm going to go over it now. So I start by rewriting the equation. And our first step again is going to be the distributive property. I want to get rid of those parentheses, so I'm going to distribute the 2 in. So negative 2 times y is negative 2y. Negative 2 times negative 1 is positive 2. And then I'm left with the same thing on the right side. Next thing I'm going to do is move the largest negative number, which in this case is 16. So I'm going to add 16 to both sides, which is the addition property. I'm just going to abbreviate that prop. So then here the 16s are gone, so I have negative 2y. 2 plus 16 is going to be 18 equals y. Again, I'm always trying to get rid of negatives, so I'm going to add again. But this time I'm going to add, sorry. Sorry about that. Add 2y to both sides. So I add 2y to both sides, which is again the addition property. And that's gone. I have 18 is equal to 3y again, which is similar to our last problem. And last but not least, I will divide by 3 again to get 6 is equal to y. If you prefer, you can write y is equal to 6, which is our symmetric property. So you can write that either way and box your answer, and we're done. Make sure you write down any questions you have for class tomorrow.